Hello everyone, thank you for joining me on my talk about our paper, the title for which is Project Level Encoding for Neural Source Code Summarization of Subroutines. I would like to thank my collaborators on this project, Saqib Haque and Colin McMillan. I would also like to thank the organizers for ICPC 2021 and everyone involved in making this a virtual conference this year due to the pandemic. The task that this paper attempts to improve upon and learn from is source code summarization, particularly automated source code summarization of header comments. These header comments, as shown on the right-hand side highlighted in red, are short summaries or any information that can help programmers understand legacy code. Here, this header comment helps a programmer understand when to use this method, which can be helpful for anyone working on this project in the future. In recent literature, we've seen the structure of code being leveraged to create better summaries for source code. In their 2020 paper, Haque used file context, which they defined as every other subroutine inside the file where the subroutine that needs the summary exists. We wanted to try to leverage a part of the project to see how it could improve source code summarization and, more importantly, what we could learn from it. Depending on the size of the project, this data can be quite overwhelming. We approached this problem by selecting files randomly up to f equal to 10 files from the project that the source code exists in. We then selected the first 10 subroutines from inside the file to represent the file. Finally, we ended up with project context, which contains f equal to 10 files, and each file contains a list of 10 methods. We used a recurrent neural network-based approach. On the left-hand side, it describes the 4 embedding spaces that we used. The first was word-level embedding, the second was subroutine embedding, the third was file embedding, and finally the project embedding. We choose W words from each subroutine and S subroutines from each file, and then F files from each project. Together, these are the hyperparameters that we use to narrow down the part of the project that we choose to encode as project context, which we then used in a simple sequence-to-sequence encoder-decoder model. Our model also consists of 2 attention layers, each for project context and the code for the method. We do this in order to understand how and what actually helps the model learn to generate better source code summaries. We observe generally positive results in terms of BLEU score. As you can see in the graphs, the BLEU score is on the y-axis, and on the x-axis are the models in their default form and with project context. On the left-hand side, you can see the results from the regular model that was described in the last slide, where each model with project context improves upon the baseline between 4 to 9%. With one exception, code-to-sequence model does not seem to improve with project context. However, as you can see on the right-hand side, we created an ensemble which consists of the project context model and the baseline aggregated at prediction. This approach has very little overhead and achieves considerably better results. Our interpretation of these results is that the models with project context improve upon a different subset than the baseline models. This is why we see a considerable improvement while aggregating these results at prediction and even code-to-sequence model, which showed no improvement previously, shows considerable improvement with the ensemble configuration. We also want our neural networks to be explainable. One way we found that project context helps create better summaries is shown here. On the left from the test set, we can see that the baseline attend-GRU model does not create a good summary for this particular method. However, the project context version of the same model creates a perfect summary, same as the ground truth for this method. We observe that the file structure for the project that this method exists in is similar to the file structure of another similar method in the training set. Hence, project context helps the model learn that these are similar functions and create a better summary during testing. As we're using considerably more data by including project context in our models, we wanted to catalog the cost difference. We observed that models with project context usually cost 2 to 3 times. This cost increase is negligible when using file context, like the 2020 paper from Haag. We expected this cost difference because the project context is bigger than file context by a factor of 10. Thank you for watching my presentation.
And now, last but not least, you have Akashi to discuss his great work. Congratulations, Akashi. So, do you imagine that your encoder could be applied to generate interactive documentation in an IDE to support project comprehension?
I don't think that we could use this in an IDE setting right now, just because of the quality of data that is used for source code summarization right now. This data is sourced from GitHub and some open source repositories, and it's just the quality of comments that the model's trained on is just not sufficient to be directly used in an IDE at this point.
Great. And what do you think about the opportunities for your encoder?
I think opportunities would be educational to help students understand code, or just source code summarization to in a virtual assistant setting where it's helping programmers understand some piece of code or fetching some piece of code online and creating automated summaries for them.
Nice. And what is the biggest challenge to apply your encoder?
It is, again, the data aspect where the quality of data is not reliable enough for the kind of things that we would like to do with this. Like in NLP domain, the data is much more reliable, and they have a lot more sources of data. Therefore, the accuracy for the same kind of encoder in NLP domain is much higher, like 70%, 75%, while we're still at a 35% accuracy mostly.
Sure, amazing. And how to collaborate with your research projects?
Anyone with access to internal data at their universities or in industry to some well-documented code, we would love any collaboration to have access to that data or work on that data.
It's really amazing because you apply some super complex approach to try to help people to understand projects in a bigger way. So thank you so much, Akashi. Join to the discussion session, and this session is over. Thank you so much for everyone to be there. It's a great pleasure with you, and I hope that you continue enjoying ICPC
Thank you.
now. Okay, see you. Bye-bye.